Humans primarily use vision to understand the world. What would happen if you're in the dark and cannot see very well? For us and quite a few other animals, touch would likely be used.
What would happen if you don't have hands and it's dark and you can't see? Some animals have overcome this limitation by using sound in a process known as echolocation. Echolocation is the use of sound waves and echoes to determine where objects are in space. Animals use echolocation for orientation, obstacle avoidance, and foraging. Two of the animals that are best known for using echolocation are bats and toothed whales.
One of the principles that allows echolocation to work so effectively is the time delay between the two receivers. The process of echolocation works by sound wave being emitted. The sound wave rebounds off objects that it hits. These sound waves go back to the animal that emitted them. The animal can use the time it takes for the sound to reach its ears and the intensity of the sound to determine where objects are in the space around it.
Animals can make echolocation sounds of varying frequencies. Low frequency sounds travel further than high frequency sounds, but high frequency sounds give the animals more detailed information about their surroundings.
Bats use echolocation to detect obstacles in flight, find their way into roosts, and forage for food. Most bats emit echolocation sounds from their mouth, but a couple of species emit the sound from their nose. When the bat emits sound and the sound rebounds towards the bat, the sound wave will hit its ears at different times. The intensity difference in time delay between the ears allows the bat to tell direction and distance of objects around them. Ascending pathways in the brainstem allow the brain to calculate the time difference between the two ears to fractions of a second.
In bats, the inferior colliculus, which is in the midbrain, receives auditory information from multiple peripherals, which it integrates and sends to the auditory cortex. The interneurons of the inferior colliculus have an extremely high sensitivity to time differences.
All these adaptations allow bats to use echolocation to give themselves a detailed representation of the world around them. Toothed whales generate sounds by passing air from bony nares to phonic lips. These sounds are reflected by the dense concave bone of the cranium and an air sac at its base. The beam of sound is then modulated and focused by a fatty organ called the melon. The melon acts as an acoustic lens since it refracts sound waves.
Whales also have large muscles on the other side of their upper jaw and surrounding bones that allows the animals to squeeze the melon into different shapes. This allows whales to direct the beam of sound.
When the sound waves hit something in front of the whale, some of the sound waves bounce back towards the whale. The whale boosts its hearing with its lower jaw, which contains a long cylindrical piece of fat running down each side. Vibrations that hit the jaw travel back to its ear, which detects the sound. Understanding the physics of echolocation allows humans to improve upon current technology through biomimetics. Biomimetics is where humans mimic biochemical processes for their own needs. Humans can improve upon sonar, which is used for many purposes, such as in subs and modern robots.
This was another example where the knowledge of physics was important to understand the biological phenomena. This was the biophysics of echolocation.